Okay. I'm not too sure if this is working. Okay. Yeah, it's my first time setting up a streaming thing on YouTube. I don't know if anyone is already here. If you are though, and you can hear me all right, I would appreciate if you can like let me know through the chatting feature here. Otherwise, I'll have to see if I can set up the thing correctly for the first maybe couple minutes. I think it's working fine. Okay. 128. Let me just set one thing. Uh okay. I will let me reopen the stream. 1 second. I'll be right back. Hmm. Yeah, I don't think okay. It was some setting, but I don't think I can change it. So hopefully this it sounds okay on your end. Um I'm not getting any responses, but I'm assuming it's working fine. I'll just leave a comment just in case. Okay. Otherwise, I'll get started. So, welcome to the AMA stream. My name is Sang Yoon. I'm one of the TAs for 1331. So basically, like the previous AMA streams, it's the same thing as ask me anything. But this time, we're gonna go over the practice exam that we released. So I'll just go over each question, kind of briefly explain what the question is about, go over it in a bit more in depth in case anyone like asks additionally through chat. Otherwise, I'll go over that first, and then I'm assuming it'll take maybe an hour to 2 hours ish for that. So after that, for the remaining 2 hours, I'll just be hanging around, doing my own stuff if there isn't any questions. But otherwise, you guys can freely ask me anything, from course materials to just general Georgia Tech stuff and even like personal stuff as well. That's fine as long as it doesn't like come over the boundaries. But yeah, it's supposed to be like a very chill environment. So there, if you can ask any questions that you had from any sources you use to study, and I'll be happy to answer them. So we'll go over the practice exam first. So first thing, so which of the following objects is eligible for garbage collection? So I wouldn't worry too much about this. Like just on hindsight, what garbage collection is like a neat feature of Java where Java itself, as it compiles, it automatically looks through your code and sees for certain objects, for certain reference types that you make or any kind of variable, if the user, the one who is programming in Java, loses access to that object, then it automatically knows, like if the user, like say, doesn't save that reference to that actual object where it exists somewhere in memory, then the user forgot it. So practically nobody can actually access the thing again. It's like inaccessible to anyone. So there's no really point in keeping it in memory. It's more efficient for Java, like for this language itself, to remove it and empty that space so that a new object could be placed there in case the user creates a new one. So that's what the garbage collection does by definition. So when you're just like looking through code, then it's simple enough. Look at the code and see if for any of the new objects, the new references that you made, if you end up losing access to it, you don't save that reference, you like overwrite the thing, then yeah, it gets removed and the garbage collector knows, the Java garbage collector knows, and it will remove it for you. So in this code, we first do string x equals hello. So this itself will create a new space in memory for hello. X will store that. And then, so X will store that address for X. And then same goes for A. It's also going to store this new object. So let's just do, I think a more cleaner one would be something like line 1, line 2, and then B, that doesn't create a new one, but just uses the reference that was stored in A. So B just basically stores the same address what A stored. And then I do A equals null. So here we're basically kind of overriding what the to address was with null. So this is one example of it. I overwrote it, but then again, Java is like the garbage collector is smart enough to know that looking through all of the variables that is still saved by the user, 2 is still used by B. So it's still active. So it won't remove it here yet. But on the 5th line, when B creates a new object, then here again, we kind of overwrite this thing. So we will create a new object somewhere else in memory and store that into B now instead of the previous address. So now no object has access to the new object we created on line 2. So this now Java, the garbage collector is smart enough to know and then remove this from memory. The last line itself, so we do new string X. So this is using the string constructor. So it'll create a whole new string instead of like reusing it from the string literal pool that we instantiated above. So this itself will also overwrite 1 with basically a new string from 6. So technically what gets removed is the 1 from line 1 and the 1 from line 2. So the correct answer would be the second one. And technically, if you want to be very technical, then you can say the third one, but I'm guessing the question itself is kind of referring to like the string like that was created on line 6 or something. So technically speaking, like these two would kind of be correct. But yeah, the one we know for sure is correct is the second option. Moving on. So what is the output of the 4-line code? So this is more on like how, like what kind of ways there are to create strings. So if we like the more standard way of creating any kind of reference type, we know the constructor. We have the new keyword and then we have the type of the object itself, and then we pass in arguments. But this is like the naive way, the standard way. And what this does is it'll create an object in the heap. That's how any other objects are made. And each time you repeat this line of code, then you just create a new object in the heap, make space for it, and that'll be the new object where it's going to be placed. Same goes for strings. So no matter how many strings you create using this new keyword, even though they are the same like content, if I create like 5 lines of new string hello, they'll all create its own space in the heap. And so each of them will have different addresses, different references. However, because people use strings so much, Java, what the devs thought was, oh, make it an easier version for them. Similar to how we use primitive types because they're most often used. So they made an easier version of creating strings, which we just use the double quotes like we've learned so far. So in this case, these strings gets placed into what's called the string literal pool. So these things are kind of separate. They are stored there, and what's also stored is like what the value of them are. So that in the case where I create another hello or another string using the double quotes, which has the same value in there, in that case, I don't want to just like throw away memory. I could save it because there's already the same string hello in memory. I already did that before. May as well reuse it. So that's what happens for these string literal pool constructions. So A and B, once I create somewhere in memory for hello for A, on line B, when I create string B, instead of creating another space and making hello here, B is also just gonna store what was previously used, A. So these two will basically be pointing to the same string, hello. C, on the other hand, we create a whole new space because this, we just always make it to the heap. So when I compare with equals, we know for objects, for any kind of reference types, these are comparing the references, right? The addresses. So A and B stores the same address, literally. So this will be true. A and C, they will store different addresses. The A is the one in the string literal pool. C is the one stored in the heap. So this is going to be false. A dot equals C. So once we use the equals function, equals method, then we know for strings at least, the implementation is so that it compares the inner actual contents of the string if each letter of the hello matches the other string. So this will give me true anytime. So we have true, false, true. So it will be the third one. Third question, what is printed after the code is run? We have args, new string 3. So we create an array of strings with 3 indices, so 3 empty spaces. And since I didn't specify anything there, all of them are going to contain null, like their default values for any kind of arrays. If it was an int, it would contain 0. If it was a double, it would contain 0.0 and so on and so forth. The strings, any kind of reference types, is going to be null. I overwrite the first element with hello, second element with what was in the args1, which we just said. So this was also going to contain hello. Then what I do is args1 dot equals args2. So string, and we use the equals for string. So it'll compare the inner actual contents, which both of them match, right? So that will be the same thing. Check will give me true. And Boolean result, we compare if args.length is lesser than 3. So this itself, yeah, args is of size 3, like that's the array. So this is false. And we see an or, right? So between like false or something, that basically means we still have to go ahead and check for the rest of it. If this thing was true, then I actually don't have to look at the rest because of short circuit evaluation, a true or something will always be true anyway. So I don't have to look at the rest, but in this case, we aren't. So looking at the second line, we do arg0 dot equals an empty string. Arg0, if we recall, we never actually set it. So it will contain its default value, which is null. So I'm trying to call an equals method on a null string, which is very bad. It will create a null pointer exception. So that will basically cause a runtime error. So because of just this part, we get a runtime, a null pointer exception, and we basically error out. Nothing gets printed out, basically. For those of you guys, okay, I think there's a bit more people now. If you haven't seen it, like if you can hear me, like if the stream just like looks fine and everything, just let me know, give me like a short comment in chat and I should be able to know. I think it's working fine, but I just don't have any guarantees. I don't know how it looks like from your end. So, but to carry on. Okay, nice. I see it. Thank you for confirming. So question 4, are there any bugs, errors in the following code? So let's see. We have scanner, new scanner, system.in. Creating a new scanner, that seems fine. We have a for loop, I is 0, I is less than 3, I++. For loop looks fine as well. We have system.out.print enter age. So this gets printed onto the user side. User will be able to type something after this space. So we type in the age and get it through scanner.nextIn. After that, we tell them to enter the name. I do scanner.nextLine for strings. That also seems fine. And then at the final line, we do name is like the name, print out the name, and we print is and then age. Everything does seem fine, but it gets a bit more complicated when we actually look at how the user interacts. So what the user will see from their end is first they'll see, sorry, enter, age, and then empty space. So think of when you are actually running your code. In your command line, what you would do afterwards is you're going to type in, say, your age, right? Let's say 23. But you don't just type in the age. In order for it, like Java and the scanner basically to see and move on, you do an extra thing. You type in enter, right? So then what actually the scanner will see in its like input would not just be 23, but it'll actually look something like this. 23 and then enter. This basically in like our like Unicode or ASCII values, it'll look like /n, the new line that we've seen so far. So this like 3 characters is actually what is seen. And if I do next int, what the scanner does is out of its input that it has, it's gonna take in the first integer. It cuts off to the very last like part that defined like gets seen as an integer, remove that thing, and then give it as an output so that it gets forced into age. That means after this line, int age equals scanner.nextInt, the enter still remains. So this is what the scanner will have afterwards. Then what we do is, I do enter name, space. And while what I think is, the user will type in their name and then press enter, what the scanner sees is the scanner code-wise, it immediately jumps off to the next line because it still has something within its like input. The enter still remained, which was previously from here. It never really got removed though. And what the next line does is similar to next int. What this thing does is it'll cut off starting from the very first, whatever the scanner has as its input, go to the very end until it sees a new line, an enter. And then it'll cut everything right before the enter, outputs that as the output, and then it'll then remove the enter for you. So on this line, string name equals scanner.nextLine, instead of the scanner waiting for a new input from the user, because it still had the enter, it will, instead of waiting for the user to type in something, it will just immediately run this thing. Sees that the enter is here. There's practically nothing right behind the enter. So like an empty string gets passed into name and then removed so that after this line, the scanner now has an input of nothing. So then if I ask for the scanner for something again, it'll wait until it gets a new token, a new input from the user. So right now, this is problematic. It never really gets the name. It just gets an empty thing for the name all the time. So what's important is after I get the int, which up to this line we know is fine, we got the int correctly, the age correctly, we need to make sure I actually remove this leftover enter, leftover new line. To do that, what we do is right after next int, I add a code that just basically throws that useless new line away. So I just do scanner, next line, just this one line goes between here. That way, this code right here, scanner.nextLine, it will give me output, this empty string, and remove the enter for me. Now, I'm not really concerned with saving that empty string, right? I know it's going to happen. I know it's useless. So I don't really have to save this thing into a string like I do in string name equals. I just need to make sure that this line does get run so that I remove the enter. So I just add that line here. But otherwise, then we are left with an empty string. And then afterwards, if I go to enter name, the scanner will actually wait before moving on to this thing because it knows itself is empty. It will have to wait for the user to pass in something and press enter. Then we'll actually get the name. Everything gets printed correctly. So the fifth one, we're asking what is printed after the call exam1, whether 12. So we pass in 12 here. Month, mod equals 12. So we're basically asking for the remainder, 12. So this will be 0. And we're looking through if there's any cases with zeros. We go through each of them, 1, 3, default, 7. So default will basically skip. We go through the cases first all the time. Sorry. So we check that there's no zeros here. So then we know, okay, in that case, I'm going to fall into default. So we run default, we print out perfect. But because afterwards we don't see a break, we're going to go through a fall through behavior. I'm going to just keep falling through until I see the very first break. So after printing perfect, I'm going to print too hot, and then I'm going to stop. I see a break, I just jump out of the whole switch. So we'll print out perfect and too hot. If I pass in 10, we also don't see a 10. So it'll also end up falling through the default, also printing too hot, and then break as well. Just double check. Yeah. Let's go to the next question. What is printed after this code is run? So we have an animal class. So this is like the parent class. Then we have the child class of that, which is dog extends animal. In the animal class, we have the count static variable, actually, interesting, which has a value of -1. So that means if I create an animal class, for any many number of animal classes I create, they're all gonna share the same variable count. If I modify the count from one animal, it's gonna affect everyone else's count as well, because it's basically the same thing. So here, the other thing we want to focus on is in the constructor, we see that we increment count by 1 every time we create an animal using the constructor. So that's interesting. And also, because this is default, we don't see a access modifier, right? So that means this is the default constructor. So as long as everything is within the same package, which we can assume so, it will also be available to the child class as well. So even dog can access count. So it's the same static variable. So if I modify count from one end, it's going to affect any other animal, any other dog from the other as well when you try to read it. So here we do animal A equals new animal. We're calling a constructor, so we basically have incremented count by 1. So at this point, count will be 0. Then we do dog D equals new dog. So if we go to the dogs constructor, we see that we explicitly called super constructor, which is the animals constructor. So at this line, we go to animals constructor, we add count by 1. So now count is 1. And after that, the animal constructor is done. We jump back and we also increment count again. So at this point, count is 2. If I print d.count, it'll give me 2. Animal E equals new dog. The static type, which is animal, and the dynamic type, which is dog, does not match. But it's fine, right? Dog is the lower child class. The animal is the parent class. We're going from lower to upper. It's an upcasting, and that's fine. It'll compile and run. So dog, we do the same thing. We increment by 1 as we call the super constructor. We increment by 1 again after running the child constructor. So at this point, now count is 4. If I do, excuse me, animal.count, which is fine, right? Because this is a static variable. I can refer to it not using just like D or E, but with the class name itself. So I can do animal.count, which will give me 4, dog.count, which will also give me 4. So we have this as the answer. What is the printed after the code is run? So let's see. We have Haynes King. We have another string array of Brent and Kay. This is valid ways to create a string, right? I can technically create a empty, like a default array using just like defining the size, or I can immediately set whatever the indices values are using the brackets and actual stuff. And for arrays, because they are iterable, I can use the for each loop as well, which if I get like the first part is going to be the type and what each indices are, how I'm going to refer to it. The second part is basically the array you're trying to go over. Then I can refer to that within the block. So here what we're doing is str string equals AR and the count. And after that, I'm going to print str character at count. And then we increment count by 1. So let's see. Array is Haynes King. So the first element is going to be Haynes. And count is set to 0 initially. So at this part, str is going to be Brent. So what we do is Brent character at count. So we're going to print out count is 0, so just B. Capital B is the first thing that we print out. And then we increment count by 1. So now count is 1. So on the second try, we do again ARR, and then count is now 1, so key basically. And I'm going to print out keys character at 1. So that will be 0, 1. So E. So I'll print out E this time. And then after that, we know the string array was done. So we leave the loop. And then at the very end, we print out array 0. Now, this may kind of confuse you because for like within the for each loop, I loop through array, the upper array, which stored in Haynes and King, put that into str, and then used it throughout. However, recall that for the for each loop, we can get elements from it. We can access each individual arrays and see this inner stuff, but we can never update it back. I can never modify the original array using a for each loop. So whatever I did here, storing a new stuff into str, modifying it, whatever, it never actually affects the original array that we were iterating over. So array is still intact. It'll have Haynes and King. So if I print out element 0, it's going to be Haynes. And yeah, so B, Haynes, and then array 1 will be King. And the plus, because these two are strings, it will concatenate them together. So it will just be B, Haynes, King. Okay. We want roll to return a random integer from -10 exclusive to 10 exclusive. Just easily put it down. Let me write it down. Inclusive, exclusive. Now, this is more of a trick question because generally, if you have a question like this, then we know the bound, like what you would generally do, any kind of a random number generating like method that we learned throughout this class, we always start with inclusive. Okay. Hopefully this is fixed. Okay. We always went through the pattern of inclusive starting from 0 to some value exclusive. It could be 1, it could be something. Now, since this thing is opposite, what you generally want to do is whatever number you get from here, you multiply that with -1. That way, the whole range gets swapped. The larger number becomes the smaller number. So it'll start with exclusive and then 0 inclusive. And then you start like shifting it based on like adding values or like decreasing values. That's one way. But here is more of tricking you because like in the final return statement, we don't see a -1 times thing. So what we kind of have to do instead is, instead of multiplying by -1, we just use the fact that this is an integer. So considering the fact that this is a range of random integers from -10 to 10 inclusive, what the actual values would look like is -9 inclusive to 10 exclusive. So technically 11 exclusive, right? So in this case, then we can see that, oh, the range of this thing is 20. So I can set like the function, assuming we can only call it for rand, would be next int. This gives me a range of numbers from 0 inclusive to the bound exclusive. So this would be the function I would call. And the bound itself, since we know the range is 20, I'm going to pass in 20 in there. And we know after this line, next int bound, we'll get a range from 0 to 20 exclusive. We need to shift it, right? So we'll subtract it by 9, and then we get our range. Feel free to, I'm going at a kind of a fast pace just because I'm guessing this will take quite a long time for us. But feel free to like put like messages in chat if you don't kind of like get anything or want me to explain again, and I'll be happy to do so. Otherwise, you can also ask that like during the AMA stream part, the second part after I cover all of this. That's also fine as well. So using the following code, what behavior occurs to toString? So we can see that in exam 2, we have its own toString. The first toString, we just return str, which is a private variable string. The second method apparently also has the same method name, but different parameter list, right? That we know, basically because like, okay, let's go with the first question first. So here we're only focusing on this thing, right? So for this phenomenon where we like two methods have the same method name, but different parameter lists, we know that is method overloading, right? So we know overloading happens, but then again, if we recall back again, any class that we build is a child class of object. An object has 3 main methods that we tend to use throughout this course. We have toString, equals, and hashcode. So toString, the one that's given from an object, also has public string toString. So with that, because we have the exact same method signature, and also it takes in no args, same parameter list, that means we are basically overriding the object's toString method. So both of them basically happens when I call toString. If I call toString 2, that's just referring to this. So object's toString, if I were to override it, everything has to match. So the method signature has to match, that which basically includes the parameter order as well. But for this one, it doesn't match the object's toString. Object's toString was a no arg method, but this thing does, right? So this will only count as overloading. Yeah, okay, so you asked why is it equivalent to going from -9 exclusive to 11 inclusive? So it's not, yeah, I mean, it's more like, so if I were to actually write this, then this would be -10 exclusive to 10 inclusive, right? So the actual values, if I convert these to integers, it will look something like -9, because we can't include -10, right? So -9, -8, -7, all the way up until 9 and 10. So these are the values that I can actually go over, which if I convert them, then that basically will also look like this. So -9 gets included, right? So I can say -9 inclusive, and I get up to 10, but not 11. So I can say 11 exclusive. So that doesn't include 11. So it's just a easier way for us to actually do it. I would say this is more of a trickier question. So like you don't have to worry too much about it. But like behind the scenes, this is my logic. Hopefully it makes sense. Let me know if it doesn't. So just to move on, which of the following is true about encapsulation in Java? So encapsulation was about like hiding stuff so that only the limited people who are actually related to it can access it. So for the first one, a class can only have maximum 10 private fields. This is something that just does not exist. So no. Private fields should be accessed and modified through public getters and setters method. Should be accessed and modified. So this isn't like something that it should be private fields once you make it private and you want to make like child classes or any other related like classes to access it, then you might make getters and setters, but it's not mandatory. So we'll put a triangle for here. Making a field protected is the best way to protect it from unwanted modification. Not really. We know the best encapsulated version is private, right? We have private, then protected, then default, then public. So protected is private is best. Class method. Private methods can be called from any subclass and any class in the same package. We know this is false, right? It can't be called from subclasses. It can't be called from same packages, only within its own class. The one that corresponds to this definition is protected. So this is false. So the best option we can see should be the second one. Next question. Which of the following correctly describes the contract between equals and hash code? So equals what the rule defines on the Java API. So you can type in Java 8 or 11 API, and it'll give you on the website basically the rules that corresponds to what equals is supposed to do and what hash code is supposed to do. Equals basically means any internal stuff, like these two objects, basically objects, needs to have the same exact like internal data, so that then it can be considered as being the same. And hash code, this is a bit more lenient. So think of it like height values for a person. I have myself and I also have my friend. This is an example I use a lot. So we both have the same height. So if I get a hash code out of both of myself, I ask the height of myself, I ask the height of my friend, they'll both give me the same 5'9". However, that doesn't mean myself and my friend are the same person. Like, we're two different people, right? So for hash codes, two different objects may give you the same hash code value. That's allowed. However, if I create a clone of myself, somehow, let's say I had a twin, then both of our heights are the same. And it should be. A twin might be a bad example, but just a clone. We both are the same exact Sangyuns, so we should always have the same height, right? So for hash code, if I call a hash code method on exactly same objects, then they should give me always the same value. However, for two different objects, they may or may not give me different values. It's totally fine if two different objects also gave me the same hash code value as well. So with that in mind, we see that if a.hashcode and b.hashcode are the same, these two integer values are the same, then a equals b must be true. This is false, right? We just discussed that two different objects hash code may be the same. If a equals b is true, two things are the same, then hash code from a equals hash code of b. This we know is true, right? If a dot equals b was true, that means a and b are literally the same objects. So if I call a hash code on one of them, it should always match the hash code of the other. Third one, if a equals b is false, these two are different objects, then a's hash code and b's hash code should always be different. False, right? Basically, the first option is the opposite. Hash code only needs to be overridden if the class is used in a hash map. Not really. You're just seen from course examples and such, you can make hash codes whenever you want. You can override them with your implementation whenever you want to. So the best answer would be the second one. This and super are always implicitly called in the first line of every constructor. A bit of a trick in words. If this was or, then this is true. So in any constructor, you either have to explicitly call these. So either start with a this constructor chaining or super, not a constructor chaining, but like a constructor call from a parent. Otherwise, unless you explicitly write that, then Java will automatically add you the super constructor call, like the no arg super constructor call. Now, it like the two with the and is the part that's wrong. Like it'll be either of them and only one of them, but not like both, because it doesn't really make sense. Like if you have both of them will always be in the first line, then yeah, which one goes first? It doesn't really make sense, right? So false. It's always either one of these, but yes, it will implicitly always be added unless you explicitly state that this constructor chaining or super constructor call. Okay, are there any bugs in the following code? A lot of code. Let's see. We have a person class with string name and string int age. We have constructors. We have our own equals method here. Or the equals, which takes an object other, which is correct signature, right? Actually, no. Public equals object other. Everything else seems fine, but equals should be returning not a void. It shouldn't return nothing, but a Boolean value, right? A Boolean value which tells me, oh yeah, both of them are equal, or both of them are not equal. So this should be a Boolean, not a void. And let's look at internal stuff. This equals other. If the references, the addresses are exactly the same, then that means, yeah, you only have one person in your computer, in your memory, and you're just trying to see, you're calling equals on literally that same person twice. So yeah, it doesn't really make sense to actually look into stuff. If there's only one person there and I'm calling it again on that thing, then it has to be the same. This is true. Otherwise, I check if other is null. If this was true, if other whatever passing is null, I just called an equals method on myself. So I know myself exists. I'm a valid person by passing null, nothing, as my argument for my equals. Does something equal to nothing? No, I know that's always false, right? So this, if this was true, then I won't do any of the ors because that's short circuit evaluation. I'll immediately go to return false. Otherwise, I know other is not a null. It is a valid, some sort of an object, a reference type. Then I can call other.getClass. This, if we recall, will give me back the class type. It's like this, like it's not too much important to know like the inner details, but it'll give you like a unique class type for each type of class. So for any person objects, if I call getClass on them, they'll give me the same exact person class type, basically. And this is the same for any person. So I can literally just use equals as well. Like using the reference type is fine. Reference comparison is fine because if I call getClass on any of the same type of the class, they'll all give me back the same exact object. So other.getClass, hopefully this gives me a person. If it doesn't equal to getClass of myself, I can, this, if you expand it, it would look something like this dot getClass. But because you're calling it on yourself, you can technically omit the this dot part. So that's why it just says getClass here. But yeah, if those two things give me the same thing, I know this getClass on myself will always give me person. So if person does not equal whatever the other class's type is, then yeah, we return false. Otherwise, if they're the same, then I'll move on, right? So here, now we know they're the same type, so I get to cast other person, other into a person and save that into person, other person. Now, because previously it was object other, because it's an object, I can't access any of its internal stuff, such as name or age. Now I can, because is of now type person. I can have access to all its inner stuff. I can do this.name. Because these are strings, I do equals. This.age, this is an int, so I do other person.age. Now, in the child class student, we have private, double GPA, private course major. So these are a double primitive data type and a reference type course. Now, if we go to override, we see that we have the first line. That seems fine. So other than the fact that there has to be a return type, the first thing is fine. The second thing is also the same thing. So we move on. Now on this part, we have student other casted to student. That's also fine. However, on these lines where we refer to name and age, we can see from above that these were private. So that means only the person class, within the person class itself, I can access it. And once I leave that, even if it's a child class, I can't access that anymore. So I can't do this.age, this.name. The only way to actually compare or check if the age and the name are equal is by using the super classes version. I get to call super the person's equals, which then will actually cast it to a person. And then since we are in the person class at that point, we'll be able to actually infer, like refer to name and age of either class and check if the internal stuff match. So instead of these two lines right here, what you want to do generally is swap it to super dot equals, and then I'll pass in other. You don't even need to exactly pass in the casted version. You can pass in other directly, the object, because it will do its own stuff. Once I pass in either an object or any other thing, it'll check if its class types are the same. And if it is, it'll cast it in its own version of the equals method, right? So I don't have to worry about casting it back and forth. I just pass in other. But then if this returns true, then that means, oh, the name and the age at least is the same. So I just need to worry about comparing the GPA and the major. So what is printed on the terminal after the code is run? Let's see. We have int a 5, b is 5. So these are basic ways to create an integer, a primitive data type. And now we have new integer b. So new integer constructor, and pass in the argument b, which is a integer value 5. Excuse me. So this, we know these are capital letter and full name characters, right? Integer. So this is a wrapper class of int. And I can, yeah, this is a valid way of constructing. And this in itself will create a whole new space in memory for reference type, this integer, and store the value 5 in there. Same goes for C. So C will store this address, let's say x123, somewhere else in memory where it actually stores 5. D also does the same. We do integer parse int. So this is a method that exists in the wrapper class integer. So it's a static method that basically converts the string, whatever I pass in, into a valid integer value. So this will convert the string 5 into an int 5. And then I'm trying to store that value 5 into an integer wrapper class. So again, I'll look somewhere else in memory, store 5 there. And in actual D itself, I'm just going to store the address 456. Then when I do a equals 6, C, a is of type int. So once I see an int on one end, or any kind of primitive data value, primitive data type, I immediately then try to convert, like the operator in the middle will make sure that both of these things are of the same type and generally are of the primitive data type to be compared to actually run the operator on. So A was of type int 5. So C, although it is an integer wrapper class, it gets converted. The integer wrapper class will get converted into a normal int. That's what we call unboxing, right? We have the box, which stores this wrapper class that stores the integer, and we're taking the value out of it so that now we can actually use the raw value itself. I'm unbox something. So we do 5 equals 5. We know that's true. We do C equals D. C was of type integer, reference type. D is also of type integer, a reference type. No primitive data types are involved here. Both are reference types. So then if it's just a reference type, we don't have to convert anything. Equals, we'll literally just compare the references, the addresses between the two, which we know are different. So this is false. C equals D. This is calling an equals method on these reference types. The equals method should have been implemented so that it compares the internal stuff correctly. So 5 equals 5 is what happens here, which we know that's true. So true, false, true would be the answer. Okay. Determine whether each field is being shallow copied or deep copied, and whether if it's safe. Let's see. So we have string model, engine. So this is a reference type. Tire, array of tire. So also reference type of reference. Array reference type of reference type is tire. An int array as well. So we do mod this dot model equals other dot model. Model was a string. This is basically a shallow copy because if I just do equals on a reference type, we know we are literally copying the address. However, we know, we know this is shallow, but it's safe, right? Because for strings, we know once I actually create a string, strings are immutable. Again, I repeat, strings are immutable. This is a very important thing. Once I set a string, save it somewhere in memory, I can never change it. Although it looks like I'm changing it, I can call methods on it to set a certain character to be uppercase letter instead of a lowercase. what happens behind the scenes is I never actually touch that already created string. I always just end up creating a new whole string with that updated value and then give that back to the user. So once I create a string, it never changes. It's immutable. So even though I just do this, put the same reference into this dot model, they both have the same addresses right now. But if I try to like change it from one end, it's never going to affect the other because it'll always end up just creating a whole new string. It will leave the original string intact. So this is fine. Engine equals new engine other dot engine. This is what we learned as a copy constructor, right? I pass in myself into the constructor of myself, and that'll create a whole new version of engine that is deep copied. It's two separate engines, but they internally have the same stuff. So this is deep copy, and we know deep copies are always safe. This dot tires equals new tire, and other dot tires dot length. So here I actually created a whole new string, a whole new array of tires of the same length. So now, right now, at this point, we have two arrays. So one, like modifying from one array wouldn't affect the other. So that seems fine. Now, after creating an empty array, I would have to copy each element into the new array, right? But when we see here, I'm doing other.tires I and copying that into this.tire. When we recall what tires type was, this was a reference type. So what I'm doing here is basically what you did right here with this dot model equals other dot model. I'm copying the reference, the address from one of these tires, and basically putting that into my new arrays index. So although we have two different arrays, within the array itself, each of them still stores reference types. And what I'm doing on this line is I'm copying the reference, the first reference to the first new index, second, third, and so on and so forth. So although we did do a bit, I did create a whole new array for it. The internal stuff are still, we face the same issue. Both of them have the same reference. So when I access index 1 or index 0 from one array that is placed somewhere, doing it from the other array will also do the same thing because both of them are storing the same reference. So this is shallow copying still, and that is unsafe. Last line is we create a whole new array. So again, we create two different arrays. And then here, each of these are ints, right? So I'm basically just copying the int value. This time, when I'm copying the value itself, but what's stored here isn't a reference, something like we just seen above. It's like integer value. So just literally like maybe 5, and 5 gets placed. This was like 1,000, then 1,000 gets placed. Because these are integers, these are not reference types, but primitive types. If I want to change the value of one of these indexes, I don't have to like go to a pointer and point to somewhere else in memory. I literally just change this value from 5 to maybe 10. And obviously it's not going to affect the other, right? So this is, generally we just say, this is deep copying. Like between primitive types, we just refer to them as deep copying, and obviously we know then that is safe. Which of the following is true about null in Java? So passing null to a method that expects an object will always cause a null pointer exception. This is false, right? We already seen ways to avoid this. In functions or methods where we take in an object such as equals, we know we can avoid this causing a null pointer exception by first checking if the thing is null. If it's null, then I'm not going to do anything. If it's not null, if it is some valid object, then I know I can call methods on it, such as getClass to see what type of a class it is. That's false. Second, null is an instance of the object class. Also false, right? Null basically means nothing. It's not even an instance. Third, wrapper classes such as integer and doubles can be assigned null. Yes, integers and doubles are reference types. These are classes. So for any kind of classes, you can assign nothing. That's like their default value. They're like very basic value, like zeros for integers or 0.0 for doubles. So yes, I can assign null to them. Calling an instance of on a null reference throws a null pointer exception. False. This is just a good thing to know. Instance of is operator where you can call like A instance of B. And it's basically checking if A replace instance of with an is-a. So A is a B. So I can do something like animal is a cat. I know that is false, right? Animal doesn't always have to be a cat. It can be a dog, it can be a dolphin, anything. So it's like the parent-child class relationship kind of got one, like it's on the wrong opposite side. So that is false. On the other hand, if I did cat is an animal, I know that is always true, right? Cat is always part of an animal. Same goes for dog is an animal. A dolphin is an animal. Those will always give me true. But either way, having a null in there will always automatically give me a false. It doesn't go through a null pointer exception. We know nothing is a animal. That doesn't make sense. It will give me false. Animal is a nothing. Also give me false. So that's one good thing of using an instance of instead of a get class. And last but not least, null is the default value for all initialized primitive types. False, right? Primitive types, they had their default values. For ints, it was like 0. Long, it was like 0L. For double, it's like 0.0 and so on and so forth. It's only for reference types that null is the default value. Explain the differences between all the visibility modifiers in Java. I'll do this verbally just because there's a lot to write if I were to do this. But you can start from the very largest, right? The one that has the most amount of visibility is public. Public can be accessed by everyone. Then we have default. We generally refer to this as package private. So anything within the package of that class. So generally, you can kind of refer to package as like the same folder, same file location. But any classes there can access it if it's default, which basically means like I don't write any visibility modifier in front of it. If it's protected, then that means I can access it within the package, and I can also access it within any subclasses. So any child class will be able to access this variable, protected variable from the parent class. Same goes for methods and such. And then last but not least, we have private, which is the most encapsulated version of it, where only within your class itself, you can access it. Okay. Worst case time complexity of removing from a linked list backed stack. So removing from a stack, that basically means I'm removing the top, right? So then the linked list version will look something like this. We know linked lists are made out of like nodes and how each node points to the next node and so on and so forth. So, and we call the first thing the head, right? So I can keep the stack, the top of the stack, the very first thing I remove as the head. If I'm removing, I just set the head, instead of what this was, I set it to a head to point to the very next one. That basically removes the first thing. This, what I only had to do was change one arrow, right? I have head save instead of the current head, maybe the arrow after the head. So this, I only had to do one operation, like basically one or maybe two if you want to be precise. Overall, just a single operation. Best case time complexity for bubble sort. This, if you think about it, since it's the best case, right? Let's think of the case where everything is sorted. I have 1, 2, 3, 4, 5. I already gave my bubble sort algorithm a sorted version. Now, the optimal version, I mean, we don't even really have to talk about the optimal version, but let's just talk about like the first large iteration, like first loop of a bubble sort. We'll first compare 1 and 2, right? These are in the correct order, so I'll just skip. 2 and 3, also correct order, so I skip. 3, 4, also correct order. 4, 5, correct order, right? I went through everything once because I had to check. That's how bubble sort works. But afterwards, let's think about what information I have. I know after the first comparison, the first element is always smaller than the second one, right? And then after the second comparison, I know the second one is always smaller than the third one. After the third comparison, I know the third one is then always smaller than the fourth one. And the fourth one is always smaller than the fifth one. So based on that, I know the first one has to be smaller than everything else. The second one is smaller than like 3 and above, but greater than 1. Same goes to 3, 4, and 5. So after the first pass, I now know that like in my sorted version, like in my sorted best case scenario, assuming that I just checked that I had to do no swaps ever, I know everything is sorted. So basically, I don't need to go over the second loop, the third loop, fourth loop. I know after my first loop, after the fact, knowing the fact that I didn't have to swap anything, everything has to be in its correct position because that's what I compared. Is the first thing like smaller than the second one, the second thing smaller than the third one, and so on and so forth. So I only had to loop through it once to check that, oh, I don't need to swap anymore. This is a valid order already. That shows that I only need to do O of n. No like further inner loops again and again. So not n squared. Let's think about best case complexity of removing from the end of a linked list with a tail. So this goes back to example above. So if I had something like this linked list, and this is a tail, right? Moving this to removing the end, what would have to happen is I have the first arrow, second arrow, third arrow, and the fourth arrow, instead of pointing, or the third arrow, instead of pointing to the tail element, it now has to point to null, right? That's what defines as the end. The tail should point to nothing. So this is the main arrow I want to change. Instead of pointing to this very last element, I want to make sure this thing points to nothing. But how do we access this? In order to change this arrow, I need to get to this node, right? The one right before the tail. And because this is a linked list, generally like the definition of a linked list, you refer to it as a singly linked list, meaning you only get one arrow, one that points from my node to the very next node only, and not back. So the only way to actually get to the one right before the tail is, instead of being able to use tail, I need to start from the very first and actually move one by one until the very one right before the end. So I can't really use the tail. Even though it says I have a tail, this still requires me to iterate through everything up until the very last. So that takes O of n. Worst case time complexity of adding to an array backlist. So if I'm adding to an array, best case would be if I have arrays, like some elements are now fixed, are filled. If I add to the very last element that was already there, I know the size of myself. So let's say the size was 4. I know 4 elements are filled. Then I know the very next element will just be filled in the 5th place. So yeah, that's fine. I know the 5th index. I can immediately do it of one operation. However, the harder case is when we know the array is now totally filled. So everything is filled. The only way to add a new element to this thing is going to the hard step of creating a whole new array with double the size, copy all the elements into my new array, and then add it to this empty space there. So because I had to copy all of my n elements into the new array, this will take me O of n. Worst case. Average time complexity of getting an element in a hash set. So the hash set itself, like the hash part of it might trick you. It's more of just basically a set, but it uses the hash code method that we were talking about before. So all of the, if you've been to some of the LeetCode questions, or like maybe some technical interviews, you might have already talked about like hash maps and stuff. What they're also using there is the same hash code method that we've just been discussing. The benefit there is that I get a number for any kind of object. It could have been a student, which has like name, GTID, like age and gender and everything. It could be an animal of size and type and all that thing. But everything, any kind of difficult object gets all converted into a simple number that I can like immediately use, right? So that means I can use these numbers to immediately know generally what the object I'm looking for. This specific student will have a specific hash code So if I know this, like whatever the internal stuff of the hash code is, I know the hash code value itself. I just immediately look through my hash set or hash map if that hash code exists. So generally here, although we talked about like the requirement of that hash code doesn't necessarily mean two different objects are the same. Like it's more beneficial, and what these data structures kind of imply is that, oh, you want to create a good hash code implementation so that that never or like rarely happens. Most of the time, 99% of the time, if I get one hash code from one thing and another hash code from another thing, if these two objects are different, they should generally give me the different hash code. So with that in mind, then all of these things, hash set, hash map, they all operate on O1. It's basically the same as accessing an array. Last but not least, worst case time complexity of clearing a linked list. Clearing a linked list basically means I have all of this. So I have all of this nodes, which starts from the head. If the thing was empty, then head basically has nothing. Like there's no nodes in there. Head, as long as head points to null or nothing, then that means my linked list is nothing. So all I have to do here is just set head to null. So O1. Which of the following are false about exceptions in Java? So finally block will still execute even if the try block returns early with a return statement. So this is, I'm pretty sure is true because finally block, finally block always runs. Oh, never mind. Okay. Yeah, my bad on this one. So I guess the only case where it won't run is when it had already left. So the method itself ended. We never actually had to get to the finally block itself. So if we do hit a return, then in that case, finally never actually runs. Or no. Okay, this is false. Yeah, okay, that I thought it was something was weird. So this should be true. So finally block, yeah, but theoretically, maybe there is some case where finally block might not run, but at least all of the cases I've seen so far throughout this course, 9 out of 10, it will always run. Whether the program crashes, whether there was an exception that wasn't caught, whether we left with return and such, it will always run itself first before doing any of that, before blowing up the computer. So this is true. Unchecked exceptions must be declared in the method signature with throws. If it's unchecked, you don't have to. So only checked exceptions are manually like required for you to add it in the method header with throws. Otherwise, you don't have to. So this one, a try block must be followed by either a catch or finally block. So you it's not. I guess, yeah, either of them. Finally block is optional, but yeah, so either of them, as long as either of them are there, then it's fine. If neither of them are there, you just have to try block and nothing else, then that in itself already doesn't make sense, and that will surely not compile. Last but not least, unchecked exceptions directly extend exception. That is, like, I guess is also kind of like a plain words. It doesn't like directly extend. There isn't like an unchecked exception class, but we refer to them as runtime exceptions, and that directly extends exception. So it's more of a play on words, but if you were being strict, then the answer would be these two. So that's that. What happens to the contents of an existing file when a print writer is created with that file name? So in this case, what happens is, like, whether, let's think about the two cases, right? If the file doesn't exist and I'm trying to write to that, like this new file using a print writer, what the print writer will basically do is it will create a new file for it and then just basically start writing on that new file. This goes the same, however, for already existing files as well, which kind of is ironic. So if there was an existing file with the same name, PrintWriter isn't eloquent enough to like read the previously existing file and like write on top, like right below it, it basically just like removes the thing. It overwrites on top of the thing as if the file didn't exist in the first place. Splat a new file on it, and then just start writing its own stuff on top of it. So it basically overwrites the thing. So existing content basically is erased and the file starts empty is the answer. Okay. Which of the identified lines will cause a compiler error? Let's see. So first line, we're using generics, which is supposed to be tricky. We have public class box t extends number. So here we're kind of giving the requirements such that the t generic type has to somehow extend numbers. So it has to be some sort of a number or below. So integer, double, all works. So under that, we have private t item, that's valid way. We have private array list t. I also can use the same generic I defined in the class. New generic, new array list, and bracket parentheses. As long as I specify on the left-hand side what exact type of the generic type I should pass in, I don't have to repeat myself on the right-hand side. So this bracket can be left empty, and that's fine. Line 7, I do pass in a t item as the constructor. I'm going to pass in item and put that into this. This still works fine. Line 10, though, right here, we create a whole new generic type E, right? So E void transfer box E other. This line itself is fine. I define the new generic that I strictly want to use within this block of like this method. However, within the method itself, I do other.item, put that into items, which is the array list that we made above, which takes in t, right? Of t, some generic type, which extends number. But there's no requirement on E, right? E never had this relationship with number. It doesn't have to necessarily be number or below. It can be anything. So when I have just this line, then E could be anything. It could be a dog or it could be a cat. It doesn't have to be a number. And I'm trying to add that into an array list for only numbers. So it could have been an integer, it could have been a double, whatever, but it has to be something below number, which is not, right? So this in itself will cause an error. You can't do this. Line 13 though. Here though, we have the wildcard, which basically you can kind of refer to it as the same thing as a generic, but just like I'm not really too keen on reusing E again. In that case, you may as well replace it with a wildcard, like a question mark, and don't have to worry about it. But you did give it a requirement for this wildcard that it has to extend T, which we know T has to extend number. So it has to be some sort of a number or below, or that's what T's requirement is. So it'll have to be even below that. So either the same thing as T or at least something below numbers. So then I know for that array list, each array list has an add all method, which takes in another array list. And that basically takes every element out of that array list and like puts that into my new items array list. So this works fine. So line 10 was questionable. This we can't run. And then in the actual main, excuse me, main method itself, we have new box 42. So this is an integer. And we know on the left-hand side, we are creating a box of the generic type integer, a wrapper class in this case. The 42 gets converted into an integer. It gets auto boxed. And then we pass it on to item. So this line works fine. Same goes for this line as well. The line 17, 3.14 gets converted auto boxed into a double, the wrapper class version, and gets placed in. The third line, so line 18, however, when I pass in hello, the string is not of type number. So when I try to create using passing the generic, like for the generic type, a string, this will immediately flag, cause a compile error because string is not of type number. So this line will not work. Otherwise, the very last line, int box is what I made above. So it's of type integer, add all, I pass in a new array list of the same type integer. So integer extends integer. It's the same thing. It works. So this line also works fine. So line 10 and 18 are questionable. Wrong. Match the properties of the correct ADTs by writing the corresponding letter. Okay. Stacks. Stacks are, or let's look at, we have stacks and queues. Let's look at each of them. Used to manage the order in which elements are processed. Generally, yeah, you would do this for queues. So once I input stuff, they all have the same, like, they all get placed, like, inputted through the same, like, order. And when I take stuff out of it, I can only take stuff out in that same order that I inputted. So that would be for A. I mean, literally a queue. I guess, although like A in itself, it doesn't strictly mention like it has to be exactly the order of like which elements went in first. For stacks, it's still stored in like a strict order, although it's not that like I get whatever I input first, output first as well. It's just that then in this case, I'm only going to be able to get stuff out that was added the last and strictly in that order only. So in that case, you can maybe refer as A for stacks as well, although I would say this is a bit ambiguous. B, elements are stored in sorted order automatically. None of them do, right? You need to do a sorting algorithm for it. Queues and stacks are generally just focused on like the specific orders of how you input stuff in there and how you get stuff out. Supports O of 1 access by index. You can't do, like, this isn't required for either stacks or queues. If you back them by arrays, then maybe sure you can, but overall, the outside part, stacks and queues aren't required to do so. You only need to have a method for putting stuff in there and getting stuff out, which getting stuff out, the order is already set. You can't really nitpick certain stuff. D, frequently used for recursive methods. We know stacks are, right? Already, if we look at like the method call stack, then that's where if I call a method, I put it into the stack, and I can never really take it out until I finish all the other methods that I ended up calling again and again. That was the whole recursive like call stack, and that reflected basically how method calls actually work behind the scenes in your computer. So that gets used, like it literally uses a stack, and queues are not really for that. Elements are added and removed from opposite ends. This we surely know is a queue, right? We add it from one end, we only get it from the other end. Elements are added and removed from opposite ends. We just did that. Follows, so FIFO ordering, the first in, first out. So that's, we know, is for queues. If it's LIFO, last in, first out, then we know that's for stack. Okay, what is returned by mystery 16 and 40? Let's call it. So we'll do M, 16, and 40. Afterwards, we do if A is 0, if B is 0. None of them are. So we go to the very last line. A is lesser than, A is greater than B. We also know this is false. So we do this line. Return mystery A and B minus A. So this line we'll call, we can do the stack form. So let's actually do it that way, just so that it helps with our visualization. So it'll look something like M16 and 24. So then again, it's not both 0. A is still smaller. Oh, A is still smaller. So we'll run M16, and if I take out, it'll be 8 this time. Now, A is still not 0, B is still not 0, but A is greater than B. So I will call mystery A minus B and B. So this time it will be 8 and 8. Again, we know both of them aren't 0, and A is not greater than B this time. So I'll run the second thing where M8 and B minus A, so 0. So now if I call this thing again, now A is, not A, but B is 0. So I'll return A. So after this call, I know I'll return 8. And that ends my mystery 8 and 0 call. That method ends now. So with that in mind, when I return back to the mystery call 8 and 8, that was within here. So this, literally, I could have replaced it with 8 and 8. So now that this ends, I got the value back. This was the return. So this also ends as well. Give me 8. Same goes for this. This will all give me 8. This also had the return. So 8 and 8. So we'll end with 8. Okay. What is the value of mid after 3 calls to binary search when searching for a 25 in the following array? So I'm guessing the value of mid is referring to like the index of where the middle index is that you're comparing. So if I just quickly count, we have 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the first middle element here would be 3, 4, 5, 6, 7. I think it should be here. Yeah, like could be a bit more keen on the exact stuff. Like in the actual exam though, I would say like these are gonna be quite straightforward. Like it will generally try to be like the exact middle element. But yeah, if not, we'll clarify for sure. But the first middle index for any kind of binary search would be this. And I'll simply compare if my whatever I'm searching for, 25, is larger or smaller than 20. It is larger, so I know it cannot be in any of the former parts. So what I'm left with is from 22 to 47. Now, again, I do the same thing. I choose the middle element, which is 29. So this was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th element is the second call. I check that 25 is lesser than, so I get to remove all of these. Now between 22, 25, 28, my third call, I'm going to refer to index 8. So 8 will be the middle value, so the middle index after the third call. So this is the answer. It's a bit ambiguous in the way how you would refer to it as value, but that was our intent. Okay, implement the sort method below that sorts the array in ascending order. You may use any sorting algorithm. I would say, yeah, this is best to look at the, we have a lot of examples either in recitation slides or in lecture slides. I guess if you're from Professor Chambers section, you might not have lecture slides, but nevertheless, there's a lot of sources on the 3 main sorting algorithms that we learned to implement at least, right? We have bubble sort, which I feel like is the most straightforward. You compare 2 adjacent elements together and see if they're in the correct order. If not, you swap, and then you repeat them. Like you do 1 loop, and then once you go through first loop, you don't have to do the very end element again. So just do like after each loop, you kind of shrink the thing. For selection sort, you go through like a similar process, but I guess like for each loop, you're trying to find in your unsorted version of the array the smallest element, or either that or the largest element. You may like choose. But based on that, you know if it's the smallest, it has to be placed on the very first part of your sorted version of the array. If it's the largest element, at the very end. So once you go through everything, you find the smallest or the largest, you put it in its correct position. On the next loop, you go through the unsorted version of the array again to find the next smallest or the next largest and put it in that corresponding spot again and again. Insertion sort was that for you have a sorted version of the array and an unsorted version of the array. And you're each iteration, you're trying to add 1 element from the unsorted version of the array into my sorted version. So at the very start, you can automatically kind of like set the first element as sorted because there's no elements in like other than that, right? So that in itself on its own, basically you can consider it sorted, right? If there's only 1 element in your array, then you don't have to swap anything, right? After that, on your actual first iteration, I'm adding my second element into my sorted version. We just have to compare once if the newly added element is like larger or smaller. If it's smaller, then I swap positions with whatever I previously had, and then I have a sorted version. If it is larger, then I don't even have to swap, and I know those two are in its correct position. On the second iteration, I'm adding a third element to it, so I do swap again and again based on like if it's lesser than the first element, if it's less than the second element, and then I get my sorted version. Each iteration, I'm kind of like enlarging my sorted version of the array and adding elements and elements from the unsorted version of the array, part of the array, basically. But yeah, I would refer to these slides or the recitation slides of these. They have the most clearest examples. Okay. Are there any bugs, errors in the following code? Let's see. We have interfaces. We have the drawable interface, which has the void draw method. So if we recall back, interfaces by default are kind of a bad choice of words. I'll try to avoid using the word default. Inherently, any method in the interface, they are considered to be public. They are considered to be abstract. So those two things I don't have to write. And it is advised to not write them because it is kind of like redundant code, right? And we don't like to use redundant code, at least in this course, if you know what I mean. So yeah, try not to use that. But with that in mind, the drawable interface has a abstract method draw that takes in no arguments, gives a no return, which, because it's an abstract method, I don't give any implementations for, right? And compared to that, I do give a concrete version of getType. I explicitly said it's a default method, which means I will give a method implementation for it, which we do system.out.print drawable. Same goes for resizable. This is also an interface. We have an abstract method void resize, which takes in a double. Also, we have a default method getType. It has the same name and the same argument list, right? As same method signature. This time it prints resizable. And on the actual, okay, this is still an abstract class, so a little different from interfaces, but still is also supposed to contain abstract methods. We have abstract void area, so another abstract method, which I don't give any implementations for. And it also implements drawable. That means within this abstract class shape, I also have an additional requirement, which is abstract, like this abstract method draw that I would have to implement. And also inherent, like a method that I do inherit in the shape class of getType. So this I don't have to override, and it will just be given to me. Now, in the actual main concrete class, Square, we say Square extends shape, the abstract class that we just discussed above, and also implements resizable. And we know within shape, it also implements drawable. So basically what it's doing is like by the hierarchy, if I squish everything down, then Square extends shape, and then it will implement both the drawable interface and the resizable interface. It just looks like it's in different hierarchies because of, yeah, the order of how I list this stuff. Otherwise, it's still the same thing. So with that in mind, we have the primitive, like the field variable, or yeah, like the class variable itself, which is not too important. We have the constructor that takes an aside. That's fine. What we want to focus on is because I don't have the abstract keyword here, if I actually did all the requirements. We have public void draw. If we look at the drawable interface, we had public void draw, right? We don't have to think about the abstract keyword anymore. And we know we have the same method signature right here, actually gave a concrete implementation. So that is valid. Let's give it a check. We have public void resize. This is from the resizable interface, right? also the same, public, void, and resize, and also taking in a double. Also gave it a valid implementation, so also check here. And then we have public void area. This also, excuse me, is also an abstract method from the shape class, public void area, no args as well. And I also give it a concrete implementation. So all three abstract methods has been completed. Okay, now this is not abstract at least. So that's a good yes, solid yes. And then in my main method, what I do is I do drawable d equals new square. Also again, so I have the static type on the left-hand side, which is of type interface drawable. And the right-hand side is of type new square, which is a concrete class. So those, the static type and the dynamic type doesn't match. However, it's still fine. Square, we don't use extends because it's an interface, but like basically it's like under the hierarchy of drawable, right? It implements drawable. So it's like it covers everything that drawable has. It has the draw method, it has the get type method as well. So this is valid. I can create, like, I know square is a valid concrete class, so I can use a constructor for it. I can store it in D because it's a parent class of it. Then when I do d.getType, however, this is a bit problematic, right? If you look at Square itself, Square basically has two getType methods. The one that it got from drawable, because drawable was implemented in shape, and shape is extended in Square, but also one from resizable. Resizable also had the concrete version getType, which gets implemented into Square. So technically, when D, we try to call getType of D, Java doesn't know exactly which part it should use the getType method form, like which implementation it should use. Should it use the drawables one, or should it use the resizables one? Although D is of type drawable, compiler would be fine. Compiler will say, oh yeah, sure, okay, D drawable, my static type has a getType method. So yeah, you can call it, that's fine, pass. But in actual runtime, when we're actually running this code, when Java tries to see, oh, what is the dynamic type of D? It's a square. Okay, I'll create a square in my memory, in my computer, and let's try to call getType on it. Then it starts fidgeting. It doesn't know exactly from where, from resizable or from drawable, where it should get the implementation of getType and call. Should it print out drawable or resizable? It does not know, so this will cause an error. So the only solution to this thing is either remove one of these, remove the getType so that there only exists one implementation, or even better, you can override both implementations, write a public void getType with no arguments and write your own version. So then whichever version that previously existed gets overridden. Both of them gets overridden by Square. That way Java doesn't have to fidget between the either of two. And that's like one error that you'd have to fix. D.draw. Then we also do the same thing again. Does drawable have a draw method? It does, right? So that is allowed by the compiler. Also run fine because Square did implement draw concrete. It gave a concrete version of it, so d.draw will run fine. On the fourth line right here, we have D, which is a drawable, but I cast it to Square, right? So now we can consider the whole block, the parentheses, as a Square type, and then trying to call resize on Square. If we look in Square, Square does have a resize method, which takes in a double, so it'll run fine. Like, it will compile fine, and it will definitely run fine as well, because the actual thing that exists behind the scenes is also a Square. On the fifth line, however, we cast D to resizable. So this D is of type drawable, right? Drawable is one interface. Resizable is a whole separate, like a different interface that exists. So this is similar to like the siblings thing that we've seen for normal classes. I have, say, cat, which is under animal. I also have dog, which is also under animal. I'm trying to cast a cat into a dog. Side casting, right? So this doesn't really work. So this doesn't work. And if we did though, then drawable, no, like even if we did, resizable doesn't have a area method if we recall above. So this in itself, even if it's a casting worked fine, I still can't do it. So either of them are wrong. You have to fix both of them. First, I need to make sure I cast not to resizable, but to shape. And then, or you can either do it to shape or to shape would be bad. Let's do square. Square would be like the most concrete version, which will actually do, like we know 100% will work. Once I cast it to a square, then I know the area method does exist for square. And also I did give it a concrete implementation, so it will always run fine. Last but not least, if I do d.getType, drawable does have a getType method. So it will do the same thing, but yeah, basically the same issue as what happened here. Both of them will not work because it does not know which getType implementation it has to call. So those two main things that you'd have to fix. Okay, moving on to Spring Boot. Which of the following annotations make a class a Spring Boot managed bean? This might, if you haven't worked on homework 9, might trick you a little. We use component and not bean. Bean was strictly for methods that like let Spring Boot know that this method, calling this method, will create like one of these instances, these specific classes or objects for you, like Spring Boot to use. Component, on the other hand, it's more of a general annotation that you can put on top of any class. And then Spring Boot knows, okay, this whole class, is constructor and this inner stuff is up to me to manage. It's not for the user. So generally for a class to be annotated, then we use the add component annotation. Which of the following best describes the primary benefit of dependency injection? So it allows the developer to manually manage the lifecycle. That's false. That's what we've been doing, kind of like the old school stuff. It reduces coupling between classes by providing required objects at runtime. True. Dependency injection is something that Spring Boot does so that I don't have to, like us programmers don't have to manage when we need to explicitly create a whole new object to use. Spring Boot will manage that for me. So this is what Spring Boot does. Third, it speeds up the application by ensuring all classes are instantiated at the exact same time. No. Fourth, it automatically writes the SQL queries needed to connect classes to the database. This is not done by dependency injection. This is done by Spring Boot JPA repository. So that converts all normal Java code, Java-like looking code into SQL code queries, basically. A user sends a GET request to API check Alice QTY0. So let's look at this and see what gets returned. So this URL always gets managed by the REST controller, right? So I found the REST controller, the annotation, and this also has the mapping API, which is exactly what we're looking for, right? We have just requested under API check Alice and QTY. So let's look at that. We have get mapping check user, right? So we can kind of assume user is the username I pass in. Exactly, we see it right here, path variable user, string name. So that's where Alice will go in. And then request parameter, I requested a default value of 1, but like since we did give it some value, we did QTY of 0. Now I actually inputted as quantity QTY, a 0 value there. And this will call service valid order, the name and the QTY. The service is referring to order service that we defined above, which is like referring to the Spring Boot service where we pass in Alice and the quantity we just passed in, which is 0. So then we go to our service class. Service class is validate order because that's the method I just called. So the name Alice gets passed in, quantity 0 gets passed in. And I immediately see 0 is less than 0. less than or equal to 0, which gets caught in this if case, and I'm going to return rejected quantity. So that will be what gets output. Okay, so this is a lot. Okay. Yeah, this is the coding question, right? I think this question was a bit cruel just because we never really covered very hard cases of enums where you have to, or enums itself contains another variable in itself. But it is something that does exist, so you can do so because there's a lot to write, and I'm a really bad handwriter. I'll just try to refer to the solution code that already exists because it's a lot. Let's see. Hopefully you guys can see. Yeah, so what we want to first do is, if we look at the instructions, we want to create an enum of 3 types. So that's like fine. That's what we've been doing so far in the class. So I can do so. Then that will just require me to have this comma, this comma, this. Either have a either end it with a semicolon, or you don't even need a semicolon. Just end it with a bracket, and that's about it. However, we have an extra thing where we say, oh, each enum needs a private double field named power. And this thing should have the first enum should have a power of 110, second 100, third 90. So that's a bit weird. However, it is something that does exist for enum. You can, after defining the enum values, you have all the list of enums, and then you end it with a semicolon. You can define enums as if you were doing it for a class, an enum's own field variable. So in this case, we do the same thing as if it was a class. I do private double power. And then we say, oh, write a constructor that initializes this field. However, enums, think of it this way. This is going to be, this constructor that I build is not really for any other users to use. It's only going to be internally used within this enum, not class, but this enum file. Once I run this enum once, initially it's going to run this constructor, but otherwise I never really have to deal with situations where people outside of this enum class, this enum file, will run my very own enum constructor. So I want to make sure only I can run it within this enum. That's the reason why we generally set, if we do decide to do so, this is a very weird particular case, but if we do decide to create a constructor for it, because now we need to set a field variable for each enum, we do set it to private. That's the general consensus, because you never really have to use this constructor elsewhere. The private, same thing. So the same enum name and double power. I'm going to set the power I pass in into this stuff power. And then because power by the encapsulation theory, we want to set everything to private. We want to give a getter method so that for each enum, there's a way for me to actually check the values, right? So we have a getter that does the same thing. Sorry. So with that in mind, then based on these things, based on the constructor more specifically, the enum declaration part above changes a bit. Instead of just defining the enum name like we used to before, now think of it this way. You're calling the constructor for each of these enums. The logica, the zone, logia, the zone, paramecia, or whatever. I never really watched One Piece, so I don't really know. But each of these lines, they're referring to the constructor. So what happens is you're passing in the double value that you want each of these enums to represent. For logia, we said we wanted a power of 110, so I pass in 110 in there. Basically, because we're requiring a double, so I'm guessing this technically is 110.0. I pass that in, and this will effectively call the constructor down here, create a whole enum object which sets the power to 110, the one that you just passed in. Same goes for zone, same goes for paramecia. So that is the effective way of creating a whole enum version of a class, right? So it's a bit complicated. I would say, like, other than looking at this one example, don't worry too much about it, because we haven't really, in the class at least, haven't explicitly covered it. But yeah. So with that in mind, yeah, stuff you want to actually do focus more on are stuff below here. So implement the contains pirate p method in the pirate crew class. So you want to utilize the iterator. So let's actually look above in the code that was provided. So we have the private class or the pirate class, which is representing the inner stuff, each thing that is stored in the main pirate crew data structure. We can kind of already see the pattern here of pirate crew being something similar to like the array list or like the linked list, whatever stores a bunch of elements, right? And each element in there is going to be pirate. So pirate, we can see that it has a name. It stores its own enum, the devil fruit. It also stores a double bounty. It has its constructor and has its equals method where it compares the inner stuff if everything is the same or not. In the pirate crew, we have one specific pirate as the captain. We have a whole pirate array, so we can kind of expect to see, okay, this pirate crew data structure has an array as its backend. Behind the scenes, everything is stored in just a simple pirate array, right? And we also keep track of how many elements there are using crew size. We have a constructor, and then we have resize, which basically says, oh, in the case where, so I can assume I'm going to call this when I run out of spaces, right? Because everything in the backend is an array. In case everything is full, I create a whole new array of pirates of double the size of what I previously had. And then I'm going to use array copy. So this, we can assume, is a method that does exist. Otherwise, you could also definitely do it manually. I would have a for loop that loops over my current array that is full and copy each element onto the new array, right? I can do that. And afterwards, I'm going to set this new array that I just created, save it into my previous array so that the array I'm keeping track of now is the new one. It has all these same elements. That's a resize. We have the iterator method, which has the same, what do you call this? The same method signature, public, and then it returns a type iterator. And we can specify, yeah, of type pirate if we explicitly want so, because we have it on the above saying, oh, this pirate crew data structure, this class, will implement the iterable interface of type pirate. So it will return us back that one. And I return a new pirate iterator. So I call the constructor for it, right? This is also, we'll look at, let's jump to the constructor itself straightforward already. You can see that, oh, there is a class within a class. That is something that you can do. And actually something that's quite helpful to know. So yes, what we've done so in the homework and what is doable is to have a whole nother file for the pirate iterator in a separate class file, create it there, write everything. So write the whole same thing. So public class pirate iterator implements the iterator. It'll have its own cursor of keeping track of where it currently is. And it will implement the two main methods that the iterator interface requires, has next method and the next method. However, if you decide to do so, think about it this way. Other than within the pirate, what is this? Yeah, the pirate crew class itself, you really don't have to use iterator elsewhere, right? For any other class. So like when we had the very default, let's say the parent class animal, in that case, it was helpful for animal class to exist on its own because I had a bunch of other child classes, a cat class, a dog class, a dolphin class, an elephant class that each extended from animal. So all of these had to use the animal class. So yes, it made sense for animal class to exist on its own because it was so useful. However, for the pirate iterator, this iterator class, it is only within the pirate crew class that this will be used. I only need access to that constructor to create it, right? Anywhere else, it really is just useless. This pirate iterator is only kind of like purpose railed towards the pirate crew data structure. So instead of having it lingering around in its own Java file so that like it's also technically exposed to other people as well, which we don't really want to do, what you can do instead is use something called a private inner class. So by having an inner class itself is what the name suggests. You can have a class within a class and make it inner. So that basically, it doesn't like inner class on its own doesn't really do much. Even though you like specify the class within itself, if you just let that class be public, that inner class public, then it basically just creates a whole new version of the class. It's just that now it's placed like within one class. So it isn't really that much useful. But the fact, what makes it useful is I can set this visibility to be private. This inner class, if I set it to be private, then only the same, like it's the same logic of how the private visibility modifier works. Only this class can access it and no other class outside, which makes sense, right? The pirate iterator only gets used within the pirate crew class and nowhere else. So it makes sense to have it private and inner, like within this class only, because only this class will use it. And in that case, then yeah, because we're in the same class, this whole thing is the same file. The pirate iterator class, this iterator, the inner class, has access to all of the fields within this class, right? It's private, which means I can access everything within this Java file, which includes not only what pirate iterator has, but also what pirate crew has. Because we're all still in the same exact .java file. That's one of the key second benefit of having a private inner class. The iterator doesn't have to go through the complicated steps of like, passing in like pirate crew and like getting getters and setters to get like its inner stuff. No, as long as it's in the same class, you don't have to do much. You can, because we're in the same class, the private stuff isn't like blocked by the inner class. It can flexibly freely access whatever pirate crew has, such as like its captain, its crew set, its crew size, which is the reason why it used directly here. In its pirate iterator's hasNext method, it directly accesses, it compares cursor with the crew size, which is a private variable of pirate crew. It can do so because it's a private inner class. It's in the same .java file. Same goes for the next method. It has to access what the pirate crew currently like has in that index where the cursor is at. But yeah, you don't have to do some complicated getters and setters for it. You just do crew set, directly access the array because, yeah, we're still in the same class. We're still in the same .java file. So no blockings there. This is like a benefit of an inner class. Anything else is all what we're supposed to write. Contains, as, is emperor, and so on and so forth. So if we look at contains, we're trying to use the iterator, right? We have successfully implemented the iterable interface. So if I call this .iterator, or I don't even need this dot, like this is more of like a additional thing you can use. So if I just call iterator, it will give me back a pirate iterator, a custom iterator for my pirate crew data structure. So once I store it in IT, then I can call the methods that IT has or iterator has. If I call hasNext, it will give me back a true or false value of there is a next element that you can call next on versus, there is no element that you can call next on, so false. So if hasNext keeps returning true, then yeah, I know I can call next. So I'll reliably call next. it will not throw me a no element exception. So then I save that into current. I check if current equals the P that I just passed in. If it is true, then I return true. If it's false, then I keep going. So I do all the while loop until hasNext is false, meaning I have reached the end. I cannot call next again, otherwise I'll get a no element exception. So I just end the while loop and return false. Adding is also similar, or more simpler, I guess. I check if the argument is valid, if P is not null, and I don't contain the thing. So it's more of a set, right? I don't want duplicate elements. Then I return. And if that is not the case, it's still everything is valid, then I check, oh, is my array actually full yet? If it is full, then that means like my back end array can't store anything. So I will have to call resize. I have to create a whole new array of double the size and save elements there. So I will call resize. Otherwise, I know there is empty space. So I just set directly add into my crew set array on this element that I know is empty, crew size, the P. And since I added a new element, I increment the size by 1. So that's what I do. Same goes is emperor. This is checking if this is more like the detail stuff. It's checking if captain has a devil fruit with power of 100 or more. So that requires us to actually use the getters method for each of the enums that we defined before, which is, yeah, good to know, but I wouldn't say like too necessary. Like it's just a good thing to know that things like this is possible and it does exist. So just an example, we'll just look at it now. I can do Boolean strong fruit. I use captain's fruit. So I immediately access the fruit, the enum from the captain, and check unless the enum was null, because that was, it said in the instructions above that enums could be null, or the captain's fruit variable, the enum for the fruit could be set to null. I first check that, and knowing that it is not null, I know then I can call the method, get power on it, check the value if it's larger than 100, and it is so, then I'll get a true here. And for bounty, I'll do the same thing, check the field variable of captain to check that it's larger, and if crew size is greater than or equal to 100, then return all the 3. So just more of like boilerplate code, not too difficult. And I'm pretty sure, yeah, this was the little bit more simpler one. So we're just trying to find devil fruit. So yeah, it's trying to look through the single pirate who has the highest bounty but currently has no fruit. So just 2 requirements, right? Going through each pirate is not too difficult. I just have a for loop that goes over each array index, and I first check if for each pirate crew that I'm iterating over, if the fruit is null. If it is, then I double check if the candidate is null, and or if if it has not been set, candidate is where I will keep information of my key pirate. Or if I already had candidate set previously, then I check if the new person's bounty is greater than what I previously stored, the previous pirate's bounty. If it is, I end up swapping whatever I previously had, either null or a past pirate, with the new pirate that I just found. So after iterating through all of the elements here, I know I'll have some valid candidate in here. If I didn't, if I went through all of the pirates and found out that there was no pirate that fitted this requirement, then I know, oh yeah, it is else. So I'll create a whole new Luffy pirate with these arguments, and I'll add that to my pirate crew. Otherwise, I will get that candidate's fruit. Update that candidate's fruit with whatever I just got in, the devil fruit that I got passed in, and set the bounty to twice the amount it was previously set. So more of also, again, just more of like requirements that you need to do, not too complicated. And this, the very last one, I would say like it's a lot of like instructions, but overall, if you go line by line, it's not too difficult. It's more like those similar homework style ish codes. Um, so yeah, like I wouldn't rush through the whole thing. I would just go line by line. If you look at the following, we say the total power is the sum of the power of every devil fruit in the crew set. So again, what I would have to do is I loop through all of the array, like the array elements I have in my pirate crew. So since I know I have implemented in my current pirate crew data structure, I implement the iterable interface. I can call on myself by passing in this. I'm passing in myself. I can call the for each loop, and that will give me back each pirate because the for each loop will just keep calling next and next on its own. So then I just check if it's not null, I'll add my fruit.get power to it. So I have this one whole thing that has every sum of the fruits. And then after that, you would consider the captain. So you do cap power. So captain's fruit. If it's not null, I add the power there. And if the emperor is true, then I also multiply it by 10. If not, I just add the normal value. And then I'm pretty sure this is yeah, the total crew's power is greater than or equal to the other crews. So I just got passed in the other, so I'm going through the same thing. I'm adding all the other pirate crews like fruit values, sum it all up, and if it is like consider the captain's power and the emperor as well. I'm just checking if my crew's sum of the powers are greater than or equal to the others' sum of the powers. So just kind of it looks lengthy, but otherwise, if you follow just line by line, calmly, it shouldn't be too much difficult. In the actual exam, it's hard to say because like I didn't like it's not in our hands, the TAs, on like how the exams might look like. It really depends on the professors, but I would say in general, the structure has always been the same. The professors would have already explained, but you have the same structure as like the exam, some sort of a short coding question, as well as like a lot of MCQs, aiming to be around like maybe an hour ish long, a little over an hour, for you to take, which will like take time to complete generally. And then after that, you have kind of like a long coding ish question where it's roughly around like think of it similar to like a PE or a homework, but not as long as that. You're only given at best like 2 hours, 50 minutes anyway. So it's more of us trying to aim you, or the professors basically trying to aim you to solve this in around like an hour to like an hour, 30 minutes, where we give you an instruction for maybe a class, maybe a data structure, or like some sort of a yeah, class may have like some requirements such as for constructors as well as for certain methods. So that might consist of like 4 or 5 like smallish, like if you try to divide that into short coding questions again, it would be like, yeah, 5 or 6 of them where you would like write your method implementation and like class details in each of them. But that's like the general structure. So like this is one example of how that might look like. But yeah, if you stay calm and like just calmly read the instructions one by one and just check if each part that you implemented, you wrote down, matches what the instruction says, then yeah, I am pretty sure you will not face any issues there. But yeah, that will conclude a quite long. Yeah, okay. I thought 2 hours. It would take 2 hours max. Just took right like slightly above 2 hours, so actually not too bad. But that will be for it for the part 1 of the stream where I cover the exam material. The second part, before I quickly get a cup of water because I've been speaking for 2 hours long, will just be me. Like I'll be around depending on how many questions I get. I might be just explaining nonstop, or otherwise, I'll be here doing my stuff as well, a couple assignments and stuff. But yeah, I'll be sticking around, so feel free to ask me in chat if you have any like specific questions on course materials, on 1331 stuff. Any kind of other stuff is also fine. It's supposed to be like a chill environment. So Georgia Tech related question is fine. Anything personal to me is fine as well. I've been here for 4 years. Just for those of you guys who are just tuning in, my name is Sang Yoon. I'm one of the senior TAs that is graduating this semester. So yeah, I've been here for a long time, taking a lot of other courses as well. I'm also an international student, so like any kind of like personal question that you're curious about, also feel free to ask, and I'll be happy to answer them. As I do stuff, and you also do stuff like I don't know, studying for 1331 or any other exam as well. It's supposed to be like a chill environment, but I'll quickly grab something to drink, so I'll be back in like 5 minutes. But otherwise, if you already have questions, feel free to just like leave in the comments and I'll definitely check back. For any questions like related to like specific like questions that you've seen, I know Study Palooza, that's what it's called, right? Done by not the TAs, but like external plus session leaders. They also give you out questions and stuff. So for if you have like specific questions there as well, or from any other part of some course material that you relied on, if it's hard to explain it in the chat system, feel free to post it on Ed discussion as well, and just like let me know in the chatting system that you left it on Ed. Then I can definitely go see the question there more easily and help you answer it. But otherwise, yeah, I'll be. Let me add this, and I will quickly be back after I grab a cup of water. Okay, 1 second. Okay. I see. I see stuff. Okay. Go over data structures that we covered and how we may be asked. to code them or like more into how the coding problems will be asked in the second part of the test or the coding section. Yeah, I get your point. This definitely is something that a lot of the other students or past students as well, they brought up. Let's see. Or before I even do that, because this is supposed to be a chill environment, let me get some chill music going on. Mm, okay. Let's see. I would like to generally for any of these, right? I like to use the ResStation PowerPoint. Okay, yeah, hopefully it shows. So for the question you asked, all of the data structures that we cover are in the ADTs. So that covers so at least like the fundamentals. Like I would focus more on the backbone, like the backend structure. So those include linked lists. That's the harder thing that we're dealing with. The structure where you have nodes which represent each index, and you go from one node to the other using each node's next field variable, right? Each node's next field variable stores like the information to the very next element. So you use that to move over. That's like the harder version. The easier backend structure was arrays. I just create a backend array that keeps track of how many elements are in there and what is the size of my current array that I have stored. So that in case where I need to make space for more elements, then I know that both of these size match. The actual size, excuse me, of how many elements are stored in my array matches the actual capacity of how much my back end array can store. So in that case, I do the same thing that we just saw from the practice exam. I do resize. I create a whole new array of double the size, and with there, I copy each element in there and then add a new element in there. So that's like two ways of how you generally in any of the data structure ish, like basically ADTs, I guess, how we manage the actual data structures. Like behind the scenes, although it looks fancy, we learned about sets, we learned about like queues, stacks. All of them behind the scenes are all backed by either an array, simple enough, or linked lists. So with that in mind, those are like the harder things that I would focus on practicing first. Then like the thing that goes on top of it is a bit more simpler. Like, so these are just for the these are slides for the linked list, which is definitely good to go over and review. But otherwise, like regards to the actual like the ADTs that we have covered throughout the course, these, like I said, it's more of the back end ish parts where it's a bit more tricky and you need to know about like, oh, how do I deal with like say adding to the front, adding to the head, or removing from the tail and such. Otherwise, like these outer like wraparound stuff, which we refer to as a stack or refer to as a queue, is quite simple. Um, I only like there's strict rules that yes, you would have to memorize. For a stack, for example, you can only like stack or like add stuff to the top and also remove stuff from the top. For queue, it was that like you can add stuff from the back, but like you can only add stuff to the back and only remove stuff from the front, and so on and so forth. For like a map, then you would always have a key connected with a like key stored with a value, and then you just have to make sure that whenever you add stuff to a set, no keys are like repeated. If there is one key already in my set with the same key, like key itself, the same value of the key, I can add it. Stuff like that. Like those are things that you definitely do need to memorize and know, like the key concepts of these ADTs, stacks, queues, set, and map. Like hash map, not really. But like maybe trees. But otherwise, like regarding to the actual implementation wise, like I said, all of these behind the scenes are either made out of arrays or the linked list. So just like I would focus more on practicing like the backend structure on how to define them, how to like declare it for like these simple add or remove operations, how you would like code for each of them for an array versus for a linked list. Other than that, I wouldn't worry too much about him. Like I repeated I said this to a lot of other students who had similar questions. For coding questions in general, we try to test you guys on, or at least this is what I felt. Now I am not the professor, so I can't be like 90% like sure on this. Although I have been here for quite a long time. So just quote me on that. Generally the theme has been that like we try to test you guys on what you have already practiced through either PEs or homeworks. So with that in mind, like unless you've been heavily tested on homeworks or in PEs on how to like create a hash map, no, we won't like test you, or you could kind of be confident that we won't test you on like, oh, create a hash map or something like that. So yes, I would definitely like, just so that you would be flexible in case any kind of question comes up, I would try to focus on like implementing more like the more general ADTs using both like an array like both an array as well as like a linked list as a back end structure. But other than that, yeah, that's like the best I can say, to be honest. Like it's not that I don't want to help anything, but just because like realistically it's not that myself. So like I really can't say. Hopefully that like answers your question though. Yeah, I did kind of see the question. I just kind of see the thing. I don't know. Where do you know where I cut off? I can repeat my explanation for that part, but yeah, if you let me know roughly which part you got and which part cut off, then I can just repeat. 30 seconds. Um, I mean, just to repeat, like the key point for what I said, I would focus more on for any of the general ADTs, like focus on swapping between the two backend structures. Make one for arrays, like one that uses arrays as a backend. Make one that uses linked lists as a backend. So practice those on the ADTs that we've kind of covered in the recitation slides at least, or not. So excluding hash maps, because obviously it uses hash code and we don't really even focus hash code that much. But everything else is like definitely fair game, like stacks, queues, sets, maps, trees. I would say already trees itself is this is more of, yeah, as long as you know the definition, it's fine. But at least up to here, these are all fair game. So I would try to focus on like if I can write implementation for this using either of the two backend structures. If not for arrays, like arrays is the more easier one, so definitely start with that one. But it would be best if you can also do it with linked lists as well. Hopefully that answers your question. Do you think we will be asked to code a linked list with like collections or iterable uh, iterator? And if so, can you give practice problems or maybe like an idea of how the problem will be asked? Um, yeah, I mean that's like fair game just because like if you look at I don't know if it was homework 7 or 8, but there definitely was I think it was 8. There was a homework where we specifically asked you to create it might have not been named linked list, but still some sort of like this data structure that implements the iterable interface. And also to separately create an iterator class that implements the iterator interface, right? So I would say like yes, I can like verbally kind of explain how any additional practice problems might look like, but like already if you look at the like if you want the best source of reference, then that's like the homework that you literally just did is like a good source of uh practice point basically. Just go over the homework and kind of I wouldn't try to do everything at once because it's just so much time taking. But at least like divide it based on like the function, like method by method, and see based on like the method description that we give you in the homework, if you can like actually write down the implementation for it that you wrote for the homework. See which parts that you miss, and then just like if you do end up like missing some major parts, then just like yeah, do it again and again until you get like used to it, let's say. Does that answer your question? Yeah, no problem. Okay. But for yeah, others as well, like I'll be here around. I'll Kellen would have previously came like he did the previous like first and second or more like the second and third AMA streams. This time around though, like yeah, he's also graduating. He's taking a lot of courses, so like he has his finals wrapped up and he's being cramped down. Myself on the other hand, yeah, I just have a couple like writing, excuse me, writing reports I have to do. Other than that, yeah, once you hit this like graduating season, you really don't have much courses that test you with stuff. So yeah, I'm here. But if you guys have any questions, just feel free to ask stuff in the comments and I'll definitely check it out. Any other questions like related to like courses you'll take based on like dreads or I don't know, internships? I honestly haven't really done any internships, so maybe that I can't say. But yeah, any other personal questions, you're also welcome to ask as well. I don't know, I feel like music is fine, but I don't know how loud it's sounding to you guys. So if you feel like it's small, I can definitely increase it, but I have no idea. Yeah, maybe it's fine. I don't know. And definitely, yeah, feel free to ask if you want me to like explain any concepts. Concepts throughout the course as well. That's like, yeah, I'm more than happy to use recitation slides or course material to just give you, yeah, explanations on any concept in the course. Uh, okay, yeah, as long as it like is just like quietly in the background, I don't think it's worry. Like if it's like so small that I like there's no point in having the music on in the first place, then yeah, I'll tune it up a bit. But as long as it's quietly there in the background and not too loud, then I'll leave it as it is for now. But yeah, your question, wildcards and generics, they'll definitely worthwhile to be on the exam, worthwhile to study for sure, because they're very important things, right? Um, yeah, like especially for wild cards, the key uh usage of wild card is that yeah, you generally use like these requirements for either it extends something, so it has to be that class or lower, or super, or like super extends is a bit weird, but you would use something like question mark super some other class. But yeah, either of them are main key ways of how you would use wildcards, just because yeah, like wildcards generally is saying it can be any generic type or any object type, and I don't really care. So the way how you generally use is yeah, you say I'm gonna replace this with a wildcard, but give it some sort of a requirement, either lower bound or a higher upper bound. And yes, that is I would consider quite important. Um, we've covered it throughout like multiple interfaces or abstract classes, and you've definitely seen it in the homeworks or PEs as well. So I would go over, if you have the time for, both the recitation slides as well as like course notes and PEs homeworks that you did. If you don't have the time, at least the implementations that you did for homeworks and PEs, and then lecture notes or recitation slides. But yeah, I would say that is like something that is critical for to understand before the exam. Like, think of it this way. I wouldn't like then again, I'm repeating myself. I didn't create the exam. But from the professor's perspective, it makes sense for them to, since we already tested exam 1, 2, 3 and all that part, for the final exam, although it's supposed to be cumulative, they would want to test you guys more on the parts that you guys weren't tested yet. So yeah, like I mean, so I guess you can say that generics was slightly covered. I don't quite remember, but nevertheless, like it's still very important. So I definitely wouldn't omit it. Ask to know something about this. The T extend comparable. Question mark super T. Yeah, nested generic. Yeah, I get what you mean. Mm, it's it's still just because like if you look from like the homework, like ones where you actually have to implement, like these, like I said, would be more connected to like the actual implementation, like or like coding questions that you may do, and like say maybe like short or like the long coding questions. There we I don't think we ever really gave some sort of an assignment where you had to write nested generic with requirements like that, like more than one in one like generic bracket basically, right? So regarding like some coding questions or like where you have to write, I feel like you can be quite confident that like those kind of questions like won't be there where we kind of like ask you to like, oh yeah, like you just typed in, which is a valid way. Yeah, it is something kind of valid. But yeah, implement with those restrictions. Although something along the lines of like what we did require you in the homeworks at least, which yeah, maybe you had generics with like one requirement, extend something with like that type, like that something, the interface or whatever the abstract class that you extend should also need a generic or stuff like that. So up to that extent, yeah, that's definitely something that we may ask in the coding portion. Definitely in the MCQs as well. But like the example you gave of doubly uh generic requirement mixed, like very complicated looking ones, I would say the maximum, the worst case you could think about if I was taking the course would be just for like maybe the MCQs. I wouldn't expect it more than that. Although it depends really on how Professor Chambers explained it throughout his lectures. Like I wasn't there myself, so I really can't say. But if he in his lecture emphasized that much for some reason, then I would be a little bit scared and be scared enough to like look into what he said during his lectures and like look through the lecture notes just to be safe. You know, that's what I'm saying. But other than that, though, in general, that's like my response. I wouldn't worry too much about it other than like what was given in the homeworks, or at least like the coding portion at least. Yeah. I do wonder which TA that is, but I'm guessing it's the TA that regularly attends the the lectures. I don't know. I feel like if it was the TA, like if the like if Professor Chambers actually brought it up first, then yeah, I would be a bit scared and look into the actual stuff, the material, right? But if it was a TA, like someone from either like the student body or like from the TAs, like they brought it up and just my Professor Chambers just like explain further in detail, then maybe it's not as bad. Yeah, I wasn't like worried too much about it. But then again, I'm like I don't want to take all credit for it, right? I'm just a very small, meager teaching assistant, not the person who wrote the exam. So don't quote me like 100% on that and like curse me when it comes on the exam. But just with a certain like feeling of guarantee based on like the experience I had throughout the course. That's what I can say. The MCQ portion of the final follow similar same formatting from the previous exams when it comes to mix of fill in the blank, conceptual, error checking. Yes, definitely. It will. I mean, yeah, in the 1% chance that I'm not too sure if you're I mean, yeah, both exams either from made from Dr. Musaev or from Professor Chambers, they do in general follow the same pattern. But yeah, in the 1% chance where either of them felt like all of a sudden the sun comes from the west side every day and like yeah, they felt cursed and they completely reorganized the whole exam. For the past like yeah, a couple years that I've been here, it's always been the same where you would have it's basically like a lengthier version of the previous past exams that you've taken. Since it's finals and it's cumulative, it's a bit more longer in general. Not just because like the time is much, but yeah, we're just trying to cover the material as a whole. But yeah, it will have all different kinds of the question that you've seen so far. No like new, sudden, like weird question. Mhm. Also, I don't know how many of you guys decided to do homework 9. I mean, yes, the less of you guys actually do decide to do so is actually, believe it or not, like helpful for the TAs because it is a bit in reality less work for us to complete, you know? We have to grade all of your stuff. But just like as a stance from a student perspective, yes, this does have a lot of like places for bonus credit. So if you have previous like homeworks where you made like kind of a slop or you missed like a lot of like the autograder questions, then yeah, I would definitely like look into that for sure. What do you recommend is the best way to practice over the next 2 days to be able to cover all the material? Mm, hard question. 2 days. I would say now you can't expect the exact same like midterm question to be on the final. But then again, if you got like questions wrong in the midterm, then that does tell you that at the time you were missing out on some of the concepts there, right? So I would go over like the past exam that you had, um, the material that we released, the practice exam that I just covered today. That's also a good one that yeah, one of the TAs and our TA team worked hard to create for you guys. But that's also good. But you only yeah, you're on a time crunch. If it's just 2 days, I would go over like I would review past exams. I would quickly skim over like the course materials. Like recitation slides are quite good. It's either that or like since you mentioned like you only have 2 days, I'm guessing you're from section A, Musaev's section. Dr. Musaev had like does release his like lecture slides as well, so you can use that. But I do feel like for studying wise, or like if you feel like you need explanations and stuff, the recitation slides are made quite concrete. Like they are very firm. So use that, especially like this week's slides, to go over all the materials. Um, if you did okay on the last couple like homeworks or P's, I wouldn't worry too much. But otherwise, I would definitely like go over the implementations that you did, so P's or homeworks that you did explicitly, especially for the last couple that we assigned after exam 3, whatever that isn't covered by exam 1, 2, 3. But yeah, that's generally my advice, what I would recommend as a whole. I don't know if you can fit everything in 2 days, but if you were to ask for firmly to prepare for everything, no. Yeah, for practice, makes sense. Hopefully, with 2 days left, you would have like finished most of the understanding part of the stuff, right? Um, I would wish you so. But yeah, in regards to practice, definitely like going over already made exams or like questions that you already solved is much faster and easier. So go over that, and same goes for like the homeworks implementations. Yeah. Oh, you guys have SIOS stuff, right? Get bonus credit. I can check where you guys are at right now. Let me check. I think it was like what, 90% for y'all to hit. Mm, it's not listed here. Yeah, 90%. I'm guessing it's the same for Dr. Musai's section as well, for section A and C. For people in A, you're currently at 57%. For people in C, you're at 53%. For people in section B, you guys are at 70%. That's a lot, okay. Yeah, I guess Professor Chambers really reiterated that or something. But I mean, yeah, it does help us a lot if you guys like do this. We get to see what we hit and what we missed and what we may end up like changing for next semester. So definitely appreciate you guys do it. Yeah, I don't know if any of you guys are from in state or out of state, but like huge respects for students who are coming from out of state. Like I don't know how you guys like moved all of your stuff, like dormitory stuff and everything, like living stuff, from where you previously lived to here. Personally speaking, um, I have to move all of my stuff out to where I'm studying in for next semester. And then, yeah, moving all the stuff from East Coast to West Coast is just so complicated. I don't know how I'm gonna be able to manage that. You guys seem quite dedicated. I don't know. I don't know how you guys manage all that. Assuming yeah, most students just like solve the practice exam, and if you guys had any parts where you got stuck, like you referred to like the answer sheet. I don't know how like was it we tried to make it a bit more difficult than actual exams, but genuinely they tend to be a bit more either complicated, time taking, or yeah, a bit more hard in general. I don't know how you guys felt for this one. Like that was our initial aim when the TA team created the practice exam. It is the first time we're doing it, so we really don't know if we're hitting it or missing it. Hopefully it was alright. Excuse me. Yeah, I felt the same as well. I mean, even for yeah, with the MCQs there, it was genuinely like a bit more trickier than how like, you would have already seen from like previous past exams. Like some of them are a bit more like we try to make it a bit more difficult by kind of winding some the explanations for questions and stuff like that. But in general, yeah, especially the coding question, we did put up a bit more context and details that you have to fulfill and stuff. Yeah, true. I get your point. That's also a bit. Uh, is there a restriction we have? Not a restriction, but like there's like a limitation we have because whoever makes the exams are different. Like the exams are made by the professors, and it's mainly like because they don't have time to create like extra exams to provide to the students. So it's really just us, the TAs, who create the the practice exams separately. So for us, we don't like. I think maybe in future semesters we'll try to maybe like reuse some of these like practice exams, or not like if not like refactor them. But now we should be able to like find any grammar issues beforehand, make it a bit more clear and stuff. But yeah, this time we're like everything is on the fly. So kind of like we definitely do have some points that we missed there. Mm. maybe I can. I thought about like most of you guys, if you would have the stream open anyway, you guys would be studying other stuff. Just have this turned on in the background. It doesn't really make sense for me to show anything in the screen in the first place. But I don't know. Biggest bit though, there isn't really much I could show. Hmm. Um, I'm pretty sure I set it that way so that like the recorded version of the stream is left. I don't know. I'm pretty sure even right now, can't you like go back and immediately start like playing from the past part of the video I saw? I can check. But I thought that was a thing. yeah, you can immediately, even right now, you can go back and like click on different parts of where I cover the practice exam. We'll try to make sure the video stays available until the last section finishes their exam for sure. After that, we'll probably hide it just because of like institutional rule reasons and such. But yeah, it should be made available for you guys to like rewatch. I think until whenever your guys' exams are at, it should be there. Yeah, yeah, no worries. Hmm.
You run with that crowd at yours, the same one that knocked you down. Why can't you stay? Even with those bruises on your heart, you're still a work of art. Why can't you stay? I've been tumbling through these thoughts, man, climbing up on trees, but now I can't climb down. I'm feeling lost, I can't complain. At least I still can feel the same. And I never wanna be the one to tell you how to feel. It's a little complicated when not everything is real. Why can't you stay? You got so much more to give and not conceal. You're not a copy, not an image, you're just real. It's written on your face, you don't wanna leave this place. Why can't you stay? And they're ripping you apart in unison, 'cause you're a painting, not a jigsaw to fit in. You tell me that it's complicated, but you're everything they hate. Why can't you stay? I know you're telling me you're fine, that I should just climb down and stop. I'll stay right here, 'cause up above the trees, I gaze through the haze that made us lose our ways. I'll stay right here. When the world around you's anything but genuine, it's hard to feel at home. That's why I'm asking you to stay, to prove to you you're not alone. I may overstep, but let me set the pieces into place. I read band on my love, I've seen good people go to waste. I'll stay right here. You got so much more to give and not conceal. You're not a copy, not an image, you're just real. It's written on your face, you don't wanna leave this place, why can't you stay?
Okay, that's simply because I'm tired of actually finishing my writing report for one of the exams. I'm just looking through a discussion post to see if there's anything interesting. I mean, one of the other TAs, oh yeah, that's fast. They already replied. But one of the questions for section A had one on, so A and C, on how to differentiate floats and doubles with printf conversion characters. So in printf, for conversion characters, you generally only have 2 for any of the numbers that you can use. You'll have %d for any type of like integers. But this includes from short, like byte and short, not only ints, but like those two, and also long. So if you use %d, you can fill in any of these and they'll automatically be like inserted in there. And if it was an int, you pass in an int in there, then a normal number will be outputted. If it was like a short, then you'd have an S. If it was a byte, you'd have a B afterwards. If it was a long, you'd have an L afterwards. And same goes for decimal. I mean, you can kind of refer, like, it's supposed to be mean floating point values, where you have like a decimal point. But if you do %f, then that both represents floats as well as doubles. So whichever one you decide to put it in that, like replace %f, if it was a float, then you'll automatically have an f behind. If you put a double there, then you have the normal value. So yeah, there's no distinction between the two. So it's more of a matter of like what value are you passing in after whatever the %d or %f you're trying to insert there. Another question was regarding like invoking methods in a class. They were asking, are there any situations where a method can be invoked without a dot operator or parentheses? I'm not too sure of parentheses. For any kind of method, you always need the method name and then the parentheses and arguments within. Now, there may be methods where you don't take in any arguments, like there's no parameters. In that case, you still do need parentheses, where the parentheses would contain just nothing. But that is definitely necessary. But compared to that, some cases, you don't need the dot operator. So the general structure for any kind of method is that you have the object name, the source of where your method is at, and then you have the dot, and then you have the method name, and then parentheses. So if you have, like, in most cases, like this one, I can't really think of any case where this will fail, but you always, as long as you have a valid like object you're calling the method from, so whatever the name of the object you define, so you give that, you put a dot, and the method, then it'll always work. However, if you're trying to invoke a method from your current class where you are writing the code for, then you generally do, to refer to your own class, you do this, use this keyword. So you would do something like this dot, and then whatever the method name is. However, for strictly like calling a method, or even sometimes like if you're referring to like the field variable for my class, like myself, then you can optionally remove the this dot part. You can omit that part and just have the method name and the parentheses. That's like another valid way of calling a method that exists for myself, wherever my current class is, like the type of my current instance, like my current classes. So this goes the same for field variables as well, the variables for the class. Yeah, so somewhere is our God, TA, Krishna immediately answered it like 5 minutes after the question was up. But yeah, just just a bit. Yeah, I don't know how all these people write these reports. Writing's really not my thing. So okay, back to writing, I guess. I'll I'll be around for like let me see if there's anything else. I see, I see. Let's see. Yeah, with streaming on this platform from the first time. There's just so many stuff I don't know. Okay, what issue is this? Let's see. What are you suggesting? Okay, that doesn't help. Hmm. I see. I see. So in that case, no idea what these are. Okay, more of a lo-fi-ish. I think this should be fine. Now I think YouTube shouldn't be yelling at me. The brink of time of ending the stream. Exams are on different days, so it will depend on which section you're in. Although, if you're from Professor Dr. Musa's section, so that's gonna be the one on Monday, Wednesday, Friday. I'm pretty sure the 825 one is on May 1st. Let's double check. It's on the living schedule, that's for sure. Yeah, you're from Professor Chambers section. It's May, I think it's 5th, but I'll like checking the living schedule is the most accurate. So if we look, yeah, it's gonna be on Tuesday, May 5th at 2:40. Yeah. Yeah. No problem. No problem. Yeah. It definitely will be similar to the midterm. That's how it has generally been throughout the years I've been teeing. So no 100% guarantee because like I'm not the professor who made the exam, but it has been so that it's always similar to the midterms, but it covers all material. It's cumulative. You'll have short coding question as well. A key thing to know is that in addition to that, you'll have a long coding question. So there it'll feel similar to like doing a PE or doing a homework. We'll have you code like a whole kind of like a fully fleshed out like class. Whether like what kind of a class depends on what question it is. It might be something from like the homework, similar to like something from the homework or PE. So like constructors, and maybe ask you to implement like maybe 5 or 6 methods, but yeah, something like that. It'll be like the long coding section is an entirely like a separate like second part of the exam. That's how we used to do it. So this whole paper exam thing, I don't know if you guys like it or not, but like believe it or not, we used to actually take like give out the exams on online. So you could have you still would have to be in the place, but you took it on your laptop. So you would still code it. However, you had no access to internet. Like you wouldn't have access to like your IDE, like your VS Code or IntelliJ. You still have to manually type everything onto like a text field basically in Canvas. That's how we used to do it. But there the structure was always that you'd have your short like your similar to midterm-ish kind of thing as like the first half section, so that we would strictly give you maybe like an hour, I don't know, like an hour 10, hour 20 minutes something. And then after that, when that time frame strictly ends, then you'll have the rest of the time strictly for the long coding question, which is like a whole separate thing. You'd have a short coding question connected to like the first part, long coding question strictly for the second part. Now we don't. Everything is combined, so it really is up to you on how much time you want to spend. But yeah, you'll have both questions basically. Short coding is going to be more like focus on testing if you guys know like these other, I don't know, like important concepts that you learn from like these other parts. So they're not really focused on like it being long and stuff, but just to test that you know how to code like those parts only, just like snippets. Okay, last minute questions. If not, hopefully I think the video should be left as a VOD. I honestly don't know, just because like it's my first time doing this. And it yelled at me. YouTube yelled at me in the middle saying like I shouldn't have had like background music with copyright claims before, which yeah, maybe I should have known, but it was just a warning, so I think it should be fine. Otherwise, I'll end the stream here. And yeah, you guys should be able to look back at the VOD, the review session. Good luck in your finals, and yeah, congrats on finishing the semester.